Today let's talk about vector addition. So let's say we had a vector. Let's say we had this vector over here and it measured 4 newtons, for instance, in the x direction. And then we added a green vector of 2 newtons in the same x direction, the same positive direction, let's say. The resultant would be this pink vector, which is 4 plus 2, or 6 units long. These vectors simply added because they are in the same direction. It's as if two people were pushing a chair. They're both pushing together. If one pushes with 4 newtons and the other pushes with 2 newtons, you get a total force of 6 newtons pushing on the vector. If these vectors were in the opposite direction, they would subtract and work against each other. But let's now analyze something just slightly different. What if the green vector, instead of being pushed in the same direction as the blue vector, was at right angles? And instead of, again, going to the right with 2 newtons of force, it goes down with 2 newtons of force. And so what we find is the resultant force on this chair, for instance, if it's the same example, would be a force that has 4 newtons of push to the right, but then 2 newtons of push down in the downward direction, for instance, in this direction. So this vector has an x and a y component, x component of 4 and a y component of 2. And we could find the magnitude of this vector by doing the Pythagorean theorem. 4 squared plus 2 squared is equal to c squared, for instance. So in general, let's say this example showed a vector that only had x components to it. This one only had y components to it. Let's say we had a vector that was just a little bit more involved. Let's say we had the second force had 3 newtons in this same negative y direction, but then 2 newtons in this direction. Well then, the resultant would be the sum of the two x components. This, again, blue vector only has x to it, 4, a value of 4 in the x direction, but the green vector has an x component of 2. So 2 plus 4 is 6. This resultant now, starting here, goes 1, 2, 3, 4, 5, 6 units to the right in the x direction. Now, the only reason this resultant vector has a y component is because the green vector had 3 newtons of vector in this negative direction, and so the resultant has only 3 units of y component to it. So again, just the take-home message here is that the resultant is always the sum of the x components of the two vectors that you're adding and the sum of the y components of the two vectors you're adding. And so let's look at one more example, that of a vector, two vectors in this direction, for instance. And so in general, we want to draw vectors or create resultants, by making parallelograms. So if we were to take these two vectors and we were to add them, we would draw a side parallel to this one. So I'm going to go 2 up and 3 up and 2 over. This side is parallel to that one. And then this side of the parallelogram is the same as this one. And so now we have a parallelogram, and we draw the diagonal between these two vectors. Again, not this diagonal to the parallelogram, but this one. And this is called the resultant, the sum of the vector sum of these two vectors. And again, we can see that this resultant has an x component that is the sum of the two x components. So that's, whoops, I put this backwards. This is 2, 3. This original vector here is 2 to the right and 3 up. So anyways, 2 plus 4 is 6 newtons of x component and 3 units only from this vector of y component. And if we wanted to find the magnitude of this result, we could do a squared plus b squared is equal to c squared, the Pythagorean theorem. So again, this has 6 newtons in the x direction, 3 newtons in the y direction. 6 squared, 36. 3 squared, 9 is equal to c squared. 36 plus 9 is 45. And then if, again, we wanted the magnitude, we just want c. We take the square root of both sides, and we find out that c is equal to the square root of 45, or about 6.7 newtons. Thank you for listening.